So in this video, we are going to discuss about the SHM of spring mass system. We are going to discuss about the time period and angular frequency of this spring mass system. Okay, so here we are considering that there is a spring of spring constant K and it is connected to a mass of object of mass M, and now it is being displaced x from its natural position. Okay, so now for calculation of the angular frequency, we are going to use the essential condition for the SHM. As we know, if any object is performing the SHM, then it will follow this equation: A equals to minus omega square x, where A is the acceleration, omega is angular frequency, and x is displacement. Okay, so now as we know here, if we displace x, this object, from the mean position, then there will be a restoring force which will be acting due to this spring, and it will be equals to kx. And because it will be acting just opposite direction of displacement, that's why we are putting here minus. Okay, now according to Newton's law, we can write down total force is equals to mass multiplied by acceleration. So we can write down ma equals to minus kx. From here we can write down a equals to minus k by m multiplied by x. Okay, if we compare this equation a equals to minus k by m multiplied by x with the a equals to minus omega square x, we can find out omega square. So omega square will be equals to uh, k by m. From here we can calculate the angular frequency. Omega will be equals to root k by m. Now as we know, time period is equal to t is equals to 2 pi divided by omega. If we substitute the value of omega, we can calculate time period, and that will be 2 pi root m by k. So this is how we can calculate the time period of SHM of spring mass system, and this will be the same way for calculating the other time period, for like calculating the time period of simple pendulum or any other type of SHM. Okay, let's end over here. Thank you.